So this is college algebra group, right? 1 week away from your test, or I think maybe you guys like moved around like with their schedule or whatever, but this is your college algebra group, and my name's Brandon. I work here at ACE as a tutor, and I'm here to help. All right, so let's get with it. Number 1. Example 1. If f of x is equal to x minus 1 and g of x is equal to 4x squared, find f of g of x and find its domain. Right, so let's work with this question step by step. All right, so we have, let me choose that f of x is equal to x minus 1 and g of x is equal to 4x squared. Let me just rewrite that on the side as 4x squared. Okay, so f of x is equal to x minus 1. G of x is equal to 4x squared. So this is a composite function, right? So I like to think of it as whenever you have whatever function we have in our x place, like we usually have an x here instead of our g of x, we're just going to substitute this function in for every single x in our outside function. So in this case, it's going to be our f function. So let me just reiterate that. For the inside function, we're going to substitute in the inside function in for every single x in the outside function. So to see how that works is that if we have x minus 1 is equal to f of x and g of x is equal to 4x squared, if we substitute of 4x squared in for every single x in our f of x, we're just going to get 4x squared minus 1, and that's going to be equal to f of g of x. All right, so let's do it the other way around. Let's say if it was, question was asking g of f of x. All right, so like I said, we're going to substitute in the inside function for every single x in the outside function. Okay, so if we're working with this now, we know that g of x is equal to 4x squared and f of x is equal to x minus 1. So we're going to have a 4 times an x minus 1 squared minus 1. All right, and that's going to be equal to g of f of x. All right, I know some questions want you to simplify this, so let's just simplify it out. That's 4 times x minus 1 times x minus 1 minus 1. That's just foiling, so it's going to be x squared minus 2x plus 1 times 4 minus 1. So we distribute that 4 inside, and we get 4x squared minus 8x plus 4 minus 1, and then simplify even further to get 4x squared minus 8x plus 3. And that is our final answer for g of f of x. All right? I know sometimes it seems daunting when it asks you to figure out the composite functions, but just think of it as the way I told you. Like if it was this case, just substitute in the inside function for every single x in the outside function, right? So do we have any questions with that? Any other questions similar to this that you want me to do? Because I think I'm gonna make some up after, so everybody could just get acquainted with these types of questions. All right. So if nobody has a question, I'm just gonna do number 2 now. Right. From the previous problem, find f divided by g of x and find its domain. Sorry for the missing s. It's a bad s. But, all right. So all this asks you is, let's go back to the previous question. F of x was equal to x minus 1. G of x was equal to 4x squared. All right. All it wants you to do is just divide these functions in the way that it asks you to. So we want f of x, or f in this case, to be our numerator, while g of x becomes our denominator, right? So if we do that, it's going to be x minus 1 over 4x squared, and that's going to be equal to our intended question of f divided by g of x, right? And then it asks you to find its domain, right? To find its domain, we want to see any trouble points that this function might have, all right? So one thing that stands out is our denominator, right? What do we never want our denominator to be? To answer that, we never want our denominator to be 0, okay? If we have the denominator equal to 0, then it becomes something that does not exist, a function that does not exist, right? So if we don't want our denominator to be 0, we can make this inequality where we have 4x squared, or equality for that matter, is equal to 0. And we solve for x in this case. So divide 4 on both sides, and we still get x squared is equal to 0. Square root both sides, and we get that x is equal to 0, right? But we don't want x to be equal to 0. Let's make it from over here more obvious, right? So if x cannot be equal to 0, that means that it is not in the domain. And to write that in interval notation, we could write it as from negative infinity, comma 0, not including 0, union 0 to infinity, right? Since we don't want 0 to be in our interval, this takes care of the fact that 0 is once again not in the interval. Okay, so let's go back to the first problem because we didn't answer something, which was find its domain, all right? And we found that f of g of x was equal to 4x squared minus 1. So if we have that f of g of x is equal to 4x squared minus 1, and we want to find its domain, one special thing about polynomials, right, is that its domain is all real numbers. So in interval notation, to say that, we say that its domain is all reals, or that's just notation for real numbers, or from negative infinity, comma, to positive infinity. Right? That's the domain for that. Since it's a polynomial, polynomials just mean, like for example, when you have something like 4x cubed, 4x to the fourth plus 2x minus 1, blah, blah, blah. Things like that, all right? Something that has something that has an exponent, something raised to an exponent. It's not dividing anything, it's not multiplying anything. All right, so remember that, because a lot of these questions are going to ask you about domains and stuff like that. So just remember that the domain of any polynomial is all real numbers. Okay, so then we'll move on to the third one. All right, so it asks, find an equation of a line with the given properties, slope is equal to 5, and containing the point 4, negative 5. All right, so what is that special formula to making an equation of a line when you have slope? In this case is m is equal to 5, and when you also have a point, 4, negative 5. Let's look back at what slope is actually equal to. M is equal to x2 minus x1 times y2 over, y2 minus y1. Did I do that right? No, hold on. Let me just do the intended question for this. All right, so if we have the slope and we have a point, then all we have to do is look at our handy point slope formula. Y minus y1 is equal to m times x minus x1. All right, what I was trying to say here, I wrote it wrong, sorry for that, is that this comes from the fact that slope is equal to y2 minus y1 over x2 minus x1, and point slope formula is just this but rearranged, right? So if anytime you might go to a trivia bar or something and it asks, where does point slope formula come from? It comes from the slope formula. All right, so moving on, we have that y minus y1 is equal to m times x minus x1. We have the point 4, negative 5, so that's x1, comma y1. We have what m is equal to, so all we have to do is now plug it in. So we have y minus of minus 5 is equal to 5 times x minus x1, which is 4. All right, so let's simplify that further. We have that y minus minus 5, that's going to be equal to y plus 5 is equal to, let's distribute it, 5 times x minus 4 is 5x minus 20, right? And now we have to solve for y because we want it in an equation in point slope form. Not point slope form, in slope intercept form. So if we do that, we subtract 5 on both sides to get y is equal to 5x minus 25. That's our final answer. All right, so remember this equation, point slope formula, very useful in more things than just college algebra. You also use it in calculus a lot when you're doing specific things, maybe like tangents, stuff like that. But yeah, just remember this. It's going to be very useful if you keep on going with like math in your career or whatever it might be. All right, so let's move on to the next one. Okay, so write the standard form of the equation of the circle of radius r is equal to 8 and center hk is equal to 0, 0. Right. So we have to recall what the standard form of the equation of a circle is. All right. So to recall that, we know, hopefully, that the standard form is equal to x minus h squared plus y minus k squared is equal to the radius squared, right? H and k, oops, that minus there. That h and k comes from the center of your circle. In this case, it's 0, 0, and your r is your radius of the circle, okay? So if we plug in all those points, or information for that matter, we have x minus 0 squared plus y minus 0 squared is equal to 8 squared, right? To simplify that even further, we have that x minus 0, so that just turns into x, and that y minus 0, that just turns into y. So if we know that, we have that the standard form is equal to x squared plus y squared is equal to 8 squared, which is equal to 64. Okay? So that's the standard form of an equation of a circle. Remember that, remember that. All right. I saw like 2 or 3 questions on like a practice test that had this certain type of question asking where the center was, what the radius is, writing something exactly like this, like what's the standard form of the equation of the circle. So yeah, just remember this equation and you'll be good to go. Okay. So any questions on this particular one? Maybe something different that has to do with this concept? No, no, okay, so I'm just gonna move on to question number 5. All right, so determine algebraically whether the given function is even, odd, or neither, or neither, or tomato, tomato. Okay, so we have that g of x is equal to negative 7x cubed plus 8. Let me just rewrite that. G of x is equal to negative 7x cubed plus 8. All right. For this type of problem, I just like to plug in a negative x, plug in a negative x wherever you see, that was terrible handwriting, wherever you see in x. All right, and we're gonna see the implications of that in a second. Okay, so if we plug in a negative x for every x in this function, we're gonna have that negative 7 times negative x cubed plus 8, right? Negative x cubed is going to give you a negative x back, so it's basically just going to be negative 7 times a negative x, so that's going to be a negative, that turns into a positive 7x cubed plus 8. All right, and that's what happens when you plug in a negative x. So g of negative x basically is equal to 7x cubed plus 8. Right? So we got back that g of negative x is equal to 7x cubed plus 8. So what does that mean? If this function were to be even, when we plugged in a negative x into the equation, it would have to bring back the same equation of negative 7x cubed plus 8. But did it? It gave us a 7x cubed plus 8, not a negative. So we can say that this is not even. Okay? Now thinking about whether it's odd or not. If it was odd, then when we plugged in a negative x, this equation would have to look like a positive 7x cubed minus an 8. All right? This would be the even version. This would be the odd. So if even, if odd. All right? So once again, if it was even, it would give you back the original equation. If it was odd, it would give you the negative of this original equation. So let's just try that out for a second. Let's make sure that this is the odd part of it is the negative of the original. So if we put in a negative times negative 7x cubed plus 8, and if we distribute that negative inside, it's going to be 7x cubed minus an 8. All right? So this equation is neither even or odd, so our answer is neither. Okay? So do you want me to run through that again? Maybe the concept of even or odd, maybe? Let me just write not even nor odd. You sure everybody's good? All right, I'm just gonna move on to the next one. Okay. So the next set of questions is kind of like preparing you a little bit for like the tests that you have up, like coming up next, because some like I think like I don't really know for a fact, but I think like maybe 2 or 3 questions are going to be questions that you've seen before in other tests. And I mean, not other tests, but your first test, right? And I just pulled like 2 or 3 questions that students usually had trouble with. But next week, I'm going to do a test review session. So it's going to be everything that you need to know for the next upcoming test. But this is basically just like a smaller, minuscule version of that session. All right. So moving on, we have 8 over x minus 3 minus 6 over x plus 8. And that is the question of perform the indicated operation, right? The indicated operation is this subtraction. So if we want to do that, the first thing that we need is to have both denominators ending up being the same exact thing. To have that accomplished, we have to multiply each side by the denominator by the factor of the denominator that's missing. So in this case, this guy is missing a what from its denominator? It already has an x minus 3. This guy has an x plus 8. So the only thing that's missing is that x plus 8. So we multiply the top and the bottom by x plus 8. So let's do that over here. 8 over x minus 3 times x plus 8 over x plus 8. And that's going to be equal to 8x plus 64 over x minus 3 times x plus 8. Keep the denominator as a factor form, because when you get into like a simplified version of this, per se, you might get a little bit confused because there's a lot of numbers going around. So just keep the denominator as a factor form for now, right? So let's do that exact same thing on the other side. What is this denominator missing that this guy does not have? This guy does not have, sorry. All right, this guy has an x plus 8, and this side has an x minus 3. So we're missing an x minus 3 from this side. So all we have to do is multiply the top and the bottom by x minus 3. Now we have 6 times x minus 3 over x plus 8 times x minus 3. Right? So let's distribute that 6 inside to get a 6x minus an 18 over x plus 8 times x minus 3. Right? And now they have the same denominators, so let's see what it's going to look like. 8x plus 64 over x minus 3 times x plus 8 minus 6x minus 18 over x plus 8 times an x minus 3. And since they have the same denominator, what can we do? We can combine them and actually perform the indicated operation of each, right? So let's combine these together as 8x plus 64 minus, don't forget that minus, please, 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 minus parentheses 6x minus 18. That minus is going to be the bane of your existence. I still have trouble distributing minuses, signs all over the place, and it gets me the question wrong every single time just for that silly mistake of not distributing that minus sign. All right, so going back to the question, I have the same denominator, so we could just put x minus 3 times x plus 8. All right, and then all we have to do is simplify like terms in the numerator. We have an 8x minus a 6x, so that turns into 2x. And we have a 64 minus a minus 18, so that's basically saying 64 plus 18. So that's going to be a 2x plus 82, if I did my math right, all over x minus 3 times x plus 8. There's our final answer. So things to take away from this is just having the same denominator should be your number one step to perform the indicator operation. And when you have the same denominator, perform the indicator operation as it is, right? But once again, if you have a minus sign in between those, don't forget to distribute inside, right? Because it'll get you the question right and won't get you the question wrong, obviously. But so yeah, that's basically all there is to this question. So let's move on. So this example is basically the same, but we're gonna have to do the same steps on the numerator and the denominator instead of just having to do it for the numerator in this case. All right, so we have that 6 plus 1 over x is being divided by 3 minus 1 over x. All right, so for these problems, I like to work at them step by step, where I separate the numerator and the denominator and then combine them in the end. All right, so the numerator is 6 plus 1 over x, right? Take that 6 as having a denominator of 1, right? It'll help you with these problems and make your life a lot simpler in thinking about what's the next step. Ooh, that 1 disappeared. Okay, so same thing as last time. What is this denominator missing that this denominator does not have? An x, right? So we're going to multiply the top and the bottom by an x. So it's going to be a 6x over x plus 1 over x, all right? And now since they have the same denominator, we could combine them to become 6x plus 1 over x as our numerator. Right? So let's work with a denominator now of 3 minus 1 over x. Okay? So, same exact steps. We have x as the denominator for this one, and 1 as the denominator for this one. So, what is this guy missing again? An x. So we multiply the top and the bottom by an x, and we have that. Ooh, what just happened? Okay. Weird, but we can move on to 3x over x minus 1 over x. Remember, they have the same denominator. Okay, so what can we do? We can combine the numerators now as 3x minus 1 all over x. Alright, and that is now our denominator. D-E-N, the den. Okay, so now we have our numerator, now we have our denominator. Now let's combine it to become one operation as 6x plus 1 over x all over 3x minus 1 over x. Alright? So if you're dividing two fractions, what beautiful thing are you going to do? In this case, it's going to be a keep, change, and a flip. Right? We keep the numerator as is, change the division sign to a multiplication sign, and we flip the denominator. So if we do all of that, it's going to be 6x plus 1 over x times an x over 3x minus 1. Alright? We multiply that across, these x's cancel, and all we're left with is a 6x plus 1 over 3x minus 1. Alright, so that is our final answer for this one. Okay. Example number 8. Almost getting there, guys. So it says, factor completely given the expression 2 times 7x plus 3 squared plus 2x plus 7 times 2 times 7x plus 3 times 7, right? That was a fancy x right here. That's just a multiplication sign. Couldn't really find this plain old x in that time, so I just use that. All right. So I know some of you guys actually have problems with this one because it says that a problem coming from calculus is given, blah, blah, blah. And it scares most of you guys, not most of you guys, but some of you guys off because of the word calculus, but don't let it scare you, don't let it fool you. This is a problem that you've done multiple times, and you should be able to keep on doing them for the rest of this course, right? So we have, let me just rewrite this entire thing, 2 times 7x plus 3 squared plus 2x plus 7 times, I'm just going to write the little dot, times 2 times 7x plus 3 times 7. All right, so that dot disappeared. Please don't disappear again. Wow. 3, 2, 1. Okay, didn't disappear. So first thing for this problem is, again, looking at two sides of the equation that we have over here, left one and the right one, right? And then I like to think, What is the same in terms of the factors that the left side has that the right side also has, right? If we know that, then this question becomes a lot simpler. So in this case, we have a factor of 7x plus 3 here, and a 7x plus 3 here. We also have a 2 out in front on the left side and a 2 out in front on the right side. So ultimately, we could cross out, or actually factor out, a 2 and a 7x plus 3. And if we do that, it's going to look something like this. 2 times 7x plus 3. What is that? I think I'm making it worse. Eraser, please. 2 times 7x plus 3. All right. And now we work with this side. We took a 2 out, so this guy's canceled. We took one 7x plus 3 out. But remember, this is to the second power. So one 7x plus 3 is still there. So 7x plus 3 plus a 2x plus 7 times, we took a 2 out, so that's canceled. I'm just going to put that as 1. We took a 2 out, so that's canceled. And we took a 7x plus 3 out. So that's also canceled. All right, and all we're left with on this side is a 7. All right, so then what we can do on the inside now is just simplify and combine like terms. All right, so then, wait, hold on. I wrote the question wrong. This is supposed to be a plus. That makes sense. Plus, this multiplication is supposed to be a plus. Let me just erase that, make it easier on the eyes. That's a plus rather than a times, because we took out a 2 and a 7x plus 3, and all we're left with on this side is a 7, right? So if we know that, we can combine like terms on the inside. Let's just rewrite it again. The outside is 2 times 7x plus 3 times 7x plus 3 plus 2x plus 7 plus 7. So combine like terms. 7x plus 2x is 9x plus 3 plus 7 plus 7. That's a plus 17. And that is our final answer. All right, let me just rerun that again because we kind of messed up right here with that being a plus rather than a multiplication. All right, same process though. Look at the left side over here and look at the right side over here. And we want to see what factors are the same. In this case, it's a 2 and a 7x plus 3. So we take those out. And then we combine like terms on what's the inside, or what's left on the inside. All right. So, any questions on this one? Maybe another example that we could do. No, maybe so. All right. Well, I'm gonna move on to the last question. Yay. Right. I forgot to write the function. Alright, so answer the following parts for this equation. X squared, x squared minus 2x plus 1. Alright, so first question, is the point -2, 15 on the graph of x? To answer that, it's quite simple actually. We know that -2 is our x and 15 is our y, and we know that this equation may be written as y is equal to x squared minus 2x plus 1. So what this question really asks you is that if we plug in an x of -2 into this, will a y of 15 come out? So let's see. We have that y is equal to -2, -2 squared minus 2 times a minus 2 plus 1. That's equal to 4 plus 4 plus 1. That is evidently 9. All right, we get that y is equal to 9, and we wanted that y to be 15, but it ended up being a 9 when we plugged in that x of -2. So in this case, is the point -2, 15 on the graph of f? This statement is false. So no, this point is not on the graph of f. All right, so all you have to do for this type of question is plug in the x value that they give you, and if they don't give you the same y value that you're given, then it is not on the graph of f. All right. Part B, if x is equal to -1, what is f of x? What point is on the graph of f? Right. So we have that y is equal to x squared minus the 2x plus 1. If x is equal to -1, what is f of x? So we plug in the -1 for all the x's. -2 minus 1 plus 1. -1 squared is 1. Minus 2 times minus 1, that's plus 2. Plus 1, that's equal to 1 plus 2 plus 1, which is equal to 4. So y is equal to 4. All right. So that's what f of x is equal to when x is equal to -1. And the next question is, what point is on the graph of f? So when we plug in of x, which is equal to -1, we get that y is equal to 4. So that means that our coordinate in this case is -1, 4 for this equation. All right, so got that. Now part C. If f of x is equal to -3, what is x? This might be a little bit more difficult. So that turns into, if f of x is equal to -3, that means that y is equal to -3. So it's going to be -3 is equal to x squared minus 2x plus 1. All right, and now all we have to do though is solve for our x's when f of x is equal to -3. Why is that minus sign keep disappearing? All right, so to solve for x, we move this -3 to the right side, so we have 0 is equal to x squared minus 2x plus 4. All right. So all we have to do now is solve for this equation for x, right? The easiest way of doing this, in my opinion, is just using the discriminant and seeing if it's real or not, all right? And seeing if the point -3 is even on the graph. All right. So we have that x squared minus 2x plus 4. And we could actually go further than the discriminant and use our lovely, lovely formula of negative b squared, negative b plus or minus square root of b squared minus 4ac all over 2a. Right, so negative b, so that's 2 plus or minus square root of b squared, so that's negative 2 squared, so that's 4 minus 4 times 1 times 4, so that's 4 all over 2a, and a is equal to 1, so that's 2. Alright, so I'm just going to erase the other parts so that we can keep going. Wow, technology. This was crazy. Okay. So negative b, that's, why did that? Okay, weird. That's 2 plus or minus square root of 4 minus 4 times 4, which is basically 4 minus 16. 4 minus 16 is negative 12. So we have that 2 plus or minus square root of negative 12 over 2. Alright, so in this case, since we have a negative under the square root, we can't really say what the x's are because they're going to give us complex numbers. But in any other case, this step right here, when it asks you the question, if f of x is equal to something, what is x? We just solve for our x's for whatever our y is. So if, let's say if it asks if f of x is equal to negative 10, then it'd be the same thing. We say that negative 10 is equal to x squared minus 2x plus 1, and then solve for our x's in this case. Okay? Same exact process. It's just that in this particular equation, we can't really solve for our x's because there's a negative inside the square root, and that once again is going to give us complex numbers, which you guys aren't going to deal with just yet, but you guys will later on in the semester. All right, so let me just erase that. Part D, what is the domain of f? This is kind of a callback to what I said before. This x squared minus 2x plus 1 reminds you of a what type of equation? A polynomial, right? So what did I say about the domain of any polynomial? And let me just say it once again. The domain of any polynomial is going to be all real numbers, right? So if we know that, then this domain of this particular polynomial, domain, D for domain, has negative infinity to positive infinity to say that it's all real numbers. All right? So it also asks for part E, list the x-intercepts, if any, of the graph of f. So what are the x-intercepts of f, or of any equation for that matter? The way to find your x-intercepts is to set your y or your f of x equal to 0. So showing that we have that 0 is equal to x squared minus 2x plus 1. After that, all we have to do is just solve for our x's to find our x-intercepts. So factoring this out, this is not too bad of a factorization problem, right? So we have an x squared minus 2x plus 1. We factor that out, and that's just going to be an x minus 1 times x minus 1. All right, we set that equal to 0, so x minus 1 is equal to 0. Right, and then x minus 1 is equal to 0. Solve for x, so x is going to be equal to 1. And that is our x-intercepts. Those are our x-intercepts. All right. Once again, just solve for your x's when y is equal to 0. Okay. All right. And if you wanted to make sure that this was true, we just FOIL it. So it's x squared minus x plus 1. So that's x squared plus minus 2x plus 1. All right. So that's part E. And finally, part F. List the y-intercepts, if there is one, of the graph of f. Basically the same thing that we did here, but instead of plugging in the 0 for our y's, in this case, we plug in the 0 for our x's. So we have that y is equal to 0 squared minus 2 times 0 plus 1. And then we solve for y. Y is equal to, that 0 squared is 0. That minus 2 times 0 is 0. And those cancel. So all we're left with is that 1. So we have a y-intercept of 1. And that is our final answer. Alright, so once again, for x-intercepts, set y equal to 0, and then solve for x. For y-intercepts, we set x equal to 0, and then solve for y.